All right, so if you haven't signed in yet, just wait. I'll put that right there. With that said, how's everybody doing today? Yeah? Woo! Everybody have a good Halloween? No? Okay. Well, let's just stop at the no. I don't need to know why. Probably best I did not to know why. But anyway, how's everybody doing with their projects? Yeah? No? It's coming along? Good. All right, so there's a couple things that I've already been asked questions about. One is that I'm getting a lot of emails and questions about where's the videos? People are going to Discord and asking where the videos are. They're not on Discord. They're actually part of the Full Sail Online website that you should be using. All right, so let's kind of go through that real quick so everybody's aware of it. One is all the lectures that we do are posted inside the course overview and inside the live lectures and archive. All right, so this is where you can sign up for, obviously, to kind of watch this lecture happening live right now. So I don't know why you would, but you know that if you want to, you can. But for the most part, the thing that you're going to be aware of is one, this right here, our lecture archive 1911. If you click on that, this is all the lectures that we've had so far. So our lecture from Tuesday, our lecture from Thursday, where you can sit there and watch them as well. Next is underneath that, if you are curious about working ahead, we also have the lecture archives from last month. So if you feel like you're going a little bit faster than everybody else, you're more than welcome to watch lectures from next week and kind of work ahead if you want to. A lot of people do that. That kind of takes a little bit of stress off of them because you have less to worry about each week. All right, so I want to make sure that everybody's aware of that. So again, remember, lectures are really going over the idea of why we do things, how we approach things. This is where we kind of creatively talk to each other. Why we do this tool? This is how we break it down. As far as step-by-step walkthroughs, those are located inside each one of these different sections. So if I go right here, one, as you walk through these, you should start seeing, different links. So we have introducing the assignment. So right here, this will go through the assignment. This will also go through how we set up projects, create projects, things like that. All right, so that will go through that part. Next is, obviously, if we go to primary forms, which is what we went over on Thursday, we also have links to how to build that step by step. And then also when you go in the secondary form, everything that I'm kind of showing today will be gone over in greater detail, where you can kind of sit there, follow step by step, hit pause, do the next thing. Those are what those are meant for. This right here is for you to kind of ask hey, why would I approach that? Why would I do this? What is a good way to model this right here? Got a question? Yeah. So yeah, if you see orange, it is something that you can click. It's a link to a video or some kind of document that we need you to see. So, any questions about that? All right. And again, definitely when I ask if you have questions, obviously if you have questions, please ask them. All right. This is a great chance to not only for you to get something answered, more than likely somebody else has that same issue or has that same concern, and you're helping them as well too. All right. All of this is part of teaching you and giving you knowledge. All right. With that said, let's kind of go over what we're doing today. So obviously, we're going to start our secondary form, which is the next phase of building. All right. So we started with primary form, which is our foundation shapes. It is the base level geometry that makes up our items, our models. All right. Think of secondary shapes as what we build on top of that. So remember, primary shapes is something that is there foundationally. All right. If we go back to that eye bolt, it was the main shape that made that. Now we're looking at that threading that went around it, which is our secondary detail. All right. Our secondary detail is when we start getting into more complex modeling and also complex ideas about how to approach modeling. That's why it's so important to make sure that we do our block out. All right. At this stage, we should not be worrying about whether or not our object's the right size, our object has the right form, the right silhouettes, or the right proportions. All that should have been figured out in the last stage, which is blocking out, because now when we start putting in that nice detail, we start dealing with more edges, more vertexes, more faces. And that becomes harder and harder to make those huge grand changes when we start adding more and more geometry. All right. So with that said, we're going to go over secondary form today. We're also going to go over the dark side of modeling, which is cleaning up an illegal geometry. All right. So everything that we built so far as we're concerned, has been, in our idea, perfect. All right. But the fact is, it's not. Maya allows you to make mistakes. And sometimes it can help cover up your mistakes. But the fact is, for us to advance into the next part of the pipeline, we have to make sure that we're going back and cleaning up this geometry, because there's stuff that may look right to us, but when it goes to the next field, whether it's rigging or animating or lighting, it may screw up their pipeline. So we have to make sure that we are going back and fixing that. And then lastly, we will be going over how we want you to turn your stuff in. Most importantly, how we want you to structure your files. Think of it this way. When you have a client and you're submitting stuff to them, they don't want everything that you've ever touched. They only want the end result, right? Same way with us. We do not need every file that you've ever created, nor do we need every image that you've ever taken a picture of. We just need what your final result is, and we'll go over what that is. All right, so obviously, modeling, secondary forms are going to break down the problems and complexities that occur as we start to add details. All right. So what is a secondary form? It's pretty much a form that can't exist by itself. It has to be built on top of a primary form, a base structure. It breaks the silhouette while it adds complexity to the main form, and it also is simple enough to actually model by hand. So far we've had our foundation shapes. Now we're getting into the more intricate details. Now there are details that realistically, it's insane for us to try to model. Think of it this way. If I look at my arm right here, so my foundation shapes would probably be the base shape of my arm, along with my hands and my fingers. Secondary form would be my fingernails, the creases on the big creases on my knuckles, things like that. Where we start getting in stuff that is going to be too insane for us to start modeling, the little tiny vein bumps on my hand, the little tiny cracks on my hand, pores, that would be too insane for me to start modeling. So we have to make sure that we are paying attention to what we can physically do and which would be too excessive, too expensive, too time consuming for us to work on. With that said, let's go over the concepts. All right. And like always, these slides are on the Discord. That's usually what I post in the 3DF announcements, so you can have those ready if you need to. Beyond that, I usually kind of keep me on track, so you'll probably see me just not use these for the rest of the lecture. All right. Now, let's talk about the concepts that we're going to use. First is edge flow and how to control it. All right, so we don't just willy-nilly put edges everywhere and try to get it to make the shape that we need. We need to make sure that our edges are working around the detail that we want to use. And we'll explain why that is important and why that helps us in the end. All right, next is punching holes into an object. This is probably the first big detail that you will usually always learn, which is how to add a hole to an object and how to do that properly. Combining multiple objects into one part. Mapping out topology, which is also part of edge flow. I need to delete that because it's up there now. And then beveling and edge quality. And then lastly, we did all this fancy stuff. Now we have to make sure that it is correct by cleaning up our problem geometry. So let's see. All right, so mapping out topology. So pretty much when we map out our topology, we have to make sure that we are paying attention to how it flows around our object. The reason why we do that is because a lot of our tools are based off the idea that it's looking at how we structure our lines, our edges, our verts. And when we actually plan out how we do our geometry, it makes our tools more predictable, all right? How many people have used insert edge loop tool so far? All right, how many people tried to do that whole double clicking an edge to select a edge loop? Right? How many people have been using those and just kind of hoping that it does what you want it to do? All right, a couple people. All right, that's understandable. It takes a bit. Like this right here, edge flow, is still a concept that even today, master modelers, they still study, they still try to improve, they try to correct, and they try to master. And the reason for that is because, one, we have to make sure that our edges wrap around a certain detail, all right? Especially when it comes to characters and humans. How we put our edges there actually influence and affects how stuff moves. So usually if you look at topology for a character, usually edges start wrapping around where muscles are, where stuff bends, things like that, because when we put edges in the proper spot, believable things happen. Like literally our muscles move properly, our arms bend properly, things like that. Same way with, you know, making sure that we actually, I always use a car analogy, all right? So how many people played Forza, all right? All those cars are looking like, you know, pretty much lifelike, right? No answer. All right, I'm gonna assume that they look lifelike, all right? They do look pretty lifelike. The fact is that they also have to pay attention to how their edge flow works on that too, because how cars look, what really gives them their appeal is how light bounces off of it, how it like goes around the contours of our car, how it sculpts around our shape of our form. And we have to make sure that our edges are going towards that, because if we mess up our edge flow on like a car like that, literally we'll see like this highlight go across our car, and then all of a sudden we get this weird flicker because it hits like a bad junction or something like that. So all of that right there, that is the artistic reason for our edge flow. The real reason that we also like to do it is because if we plan out our edge flow, all our tools become predictable. Like I will be using a lot of tools that will pay attention to edges this today and going forward in the rest of the month. Same way when you go into model creation, you'll be using more and more tools that are going to take advantage of your edge flow. And if you plan out your edge flow, then your model becomes predictable. Like literally you can look at it and go like, all right, if I use this tool, it will do exactly this, all right? I know it before it happens. Now, I keep on saying edge flow. Edge flow, edge flow, edge flow. What does that mean? So, let's go ahead and get my example up. So a lot of times, like let's say we're using this example right here. A lot of times what happens when people try to model, they do something what I call grid-based modeling, where they'll just throw in a whole bunch of edges and then they hope like they can go in there and start moving edges to make the shape that they need. And that usually looks like this. Go right here, make a plane. And wireframe on shaded. And if I want to make this a little bit see-through, but still have a little bit of shadiness on it, I can go and turn on X-ray. That will give me a little bit of transparency. But when we talk about grid-based modeling, this is what I'm talking about. Like literally, we just throw in a whole bunch of edges, and then we just start yanking stuff around, hoping that we make the shape that we need. And that is very common for when you first start out modeling. And obviously, I'm not going to go around and do all that, but let's say I want to get the inner dip right there, so I just start grabbing that. Now, if you're seeing me do something that you're not understanding or you don't know how to do, stop me. Just say, hey, what are you doing? Like, how are you approaching that? Now, obviously, be aware what I'm doing right now, I'm showing you the wrong way. But if you're curious, if you haven't gone to like the whole idea of going in the vert mode and yanking your verts where you need them, definitely ask those questions. But anyway, let's just kind of like make believe that I went ahead and just did this whole entire thing. This is where we get into the issue of edge flows, because now my edge flow is not predictable. Literally, when I say edge flow, when I click on an edge, where does that go around? What does it follow? If it doesn't follow around the detail that I want it to, I'm not really setting up that edge flow. It's just willy-nilly going around. And the reason why that's important is because later on we will have a phase called polishing off and edge quality, where we need to make sure that we browned out edges. We add some sort of realism. When we need to go extrude, or when we need to go and add in insert edge loops. All that kind of goes away if we don't plan stuff out. So if we go right here, And I'm gonna hold down Shift right click. And I'm going to insert edge loop tool. So if I was to click right here, can anybody guess where this edge would go? Yep, directly to the left, and then it's bam, it's going to go straight over here. Exactly. Where should it really go? If I'm putting like an edge loop that is going around this rim, where should it go? It should follow around that track of our object. So think of edge flow as edges that holds our contours. How many people have ever done any contour drawing, where you draw like the main shapes that make up your object? Same thing with right here. We want to make sure that those edges go through our main shapes. They support them, they hold them. So what does that look like? Well, first, as always, we don't want to just throw stuff down and start, modeling. We want to have a game plan. So how do we plan out edge flow? Well, we already have an image. How about we start drawing on top of it? So I'm sure Mac has their own version of this, but I use Epic Pen on Windows. And what it allows me to do is literally just start drawing on my screen. And what we want to do is just kind of trace out where our main shapes are. So what is the main shape for this one right here? What's the main thing that holds up my silhouette for that little pop top? What? Huh? What? Oval. Another thing is that like we're not looking for like primary shapes. We're looking at like what is the main shapes that we have. So first off, honestly, we have the actual outside of the whole entire thing. So that's our first contour line. Next is obviously the inside right here. We do have a circle right there. So those are the main shapes that we're trying to hold. Now, one of y'all already started saying it. We already see where we have like, a circle or oval where we can start kind of going out from there. That's where we start breaking down like, all right, what's the primary form that we can start with? So what does this part look like? Circle. Which one of our three primary shapes has a circle? Cylinder. So like a top of a cylinder, right? So that usually looks like a little pizza pie. So I'm going to go right here. I'm going to draw out little corners. Now we can kind of see where this can start like flowing into itself right there. So that obviously can extrude out and start making that. We can see like there's a little break right there, so we need to put one right there. And again, this is not something that you're going to get very quickly. Like this is going to take months, years for you to get used to how we actually start breaking down edge flow. But we can start seeing where we can start making extrudes out. So that's making extrude, that's making extrude. Now we do see where we're starting to have areas where we need to collide. This is what I usually talk about putting up fences, all right? So we have one prominent like shape. We need to make sure that we keep that shape safe before going into another one. So usually what I call it is putting up a barrier. This is going to become more important when we start using poking in holes. So what I'll do is kind of divide that. And now we can kind of keep on going. And then we can keep on like drawing this out. And then we can kind of see that these can probably crisscross into each other. So now, obviously, probably a lot of this is not making sense because right now we're just drawing stuff out. We're drawing out lines to kind of get that edge flow, that skeleton onto our object. Until you get used to actually working with polygons and seeing their limitations and what you have to do to get them, some of this will be trial and error. The best thing I can always say is, one, always pre-plan. What's up? Yes, you can. Definitely go to, like, how many people have used, actually, by default, your Macs don't really have function keys, all right? So how many people have managed to hit F1 on their keyboard? All right, so what happens when you hit F1? It's a hotkey in Maya. What? Nope. It brings you to help. It will bring you to the actual document that literally, if you have any questions, like you're curious about a tool that's not taught inside of 3DF, you type it in there and it'll tell you exactly what it does. That's a grease to learn about the grease pencil, because while it's not as versatile as Blender's grease pencil, I believe that Blender's grease pencil is a game changer. It still has its own functionality that you can play around with, and can definitely do out like little draw outs right there if you want to, right? There's a whole different level with that right there, so it's definitely worth checking out. Now, with that said, let's kind of implement what we just saw here. All right, so we started with, we already talked about, gotta get back my little cursor. All right, so we already said cylinder. Cylinder would be a great way to start this, right? Yes, no, maybe? All right, so first pro tip, anything that you have that has thickness, model it flat. All right, model it without any thickness. Can anybody think of a reason why we would want to do that? What? There's less edges to mess up, yeah. All right, so think of this right here. The more geometry you have, the more you have to worry about. That's the same shape pretty much on top and bottom, right? It's not going to change drastically. So why do I have to worry about, if I need to move this vert, making sure that I also grab the one underneath it and the one that may be underneath that as well too. I can just worry about it on a 2D level, because here's the thing, we can always add thickness later, and we will be doing that several times a day. Actually, we'll be doing it on this one right here. So how do I make this flat? Let's think about that. How do I make this into like just a flat top? I could scale it down, but then I'm just putting like faces on top of faces. But that's a good idea. What's up? Delete the faces. So somebody said first we could scale down, which again, that goes into the issue of we're going to have faces on top of faces, which, yes, and that will actually make it into problem geometry. Trust me, y'all will have nightmares over problem geometry. Yes. So, and another person said, well, we can just grab those faces and then we can just delete them. So, to do that, we're gonna go and just select them and hit delete. Now, I want you to be aware of what I just did. I deleted those faces using the delete key or the backspace key. I'm not walking over, I think it's delete. All right. I did on faces. That's very important to make that distinction. That is not something that you can do with edges. And we'll explain why a little bit later on this class. But that is the distinction that you need to make sure of. All right, so now we got those faces. I can go right here and scale it down. All right, so edge flow wise, if I want to start going into this area, what should I do? Extrude. Extrude what part? Well, obviously the edge, but do I extrude all of my edges? What? The bottom part of the circle, exactly. This is where we start playing stuff out right there, and that's exactly, we're seeing where our edges are leading us. So if we go right here and select these, shift right click, extrude. I'm just going to bring these down. I can also scale them out so we can start making that shape. All right. So now, what should I probably start doing? What? Insert edge loop? Where? So tell me warmer or colder as I go. Right there. Why? That's exactly it right there. We're starting to go into a new form. We need to start putting in our barriers. So right there, we can see where the form is. So I can go right here, shift right click, insert, and then we add that in. Now we can do a little bit of tweaking. So that's looking fine right there. And I could probably bring this up a little bit more to fan this out. I will tell you honestly, moving around verts and tweaking out your shape, that is pretty much the keystone of modeling, all right? Everything can't be like a quick press or moving around. Getting in there, getting dirty with the verts, moving them around, that's one of the main things about modeling. So don't be afraid to do that. If you need to go in there and tweak it out, go for it, all right? So this brings us to our next thing. So what do we do now? Where do we start pushing our form to? Yeah, extrude up. So we need to start making and creating that, extending out the shape. So now one of the things right here is, so I told you like 4 different ways how to extrude, right? All right, so which one did I tell you to be careful about? Shift, all right. So some of you are probably going like, well, if I need to be careful with shift, why is it there? It's because of this right here, where I can go and hold down shift and start bringing it up and very quickly kind of get those extrudes out. That is the case that I would say that you would want to use shift, mostly because, one, it's flat. There's no other geometry there. We're not having to worry about accidentally selecting a face in the background and accidentally extruding it, because that is the thing about extruding. Extruding is a very powerful tool, but it's also one of those things, if you accidentally extrude, it's like a snowball effect. It will just steadily F up your geometry to the point where you'll have to restart. I'm not going to lie. So when you do extrude, especially starting out, double, triple, and quadruple check your stuff. Always double check to make sure, like, hey, did I properly extrude that? But yeah, we just go right here, hold down shift. I'm just going to start moving this around. And again, going back to also what I'm saying about curves, we do not need to make sure that we add a point for every minute change in our curve. The reason for that is we can always add in more geometry later. So if that's a little bit too jagged, we just go right here to my multi-cut tool. So again, that's shift right click in object mode, multi-cut, and then we can hold down control to turn that into a insert edge loop, and then just tweak it out. We can always add in geometry later. Granted, we can also delete geometry later, but sometimes it's harder to remove geometry than it is to add it. So All right, so we said that something needed to happen here. Does anybody remember what we had, happens there that we need to account for? Yes, so he said that there has to be a line across. So let's kind of go into why that line has to be there. So if we notice right here, we're going back to our contour lines. We have three major shapes kind of meeting up with each other. This is almost like those storms and, well, obviously a perfect storm. Right here. Oh, this doesn't kill anybody though. All right, so we have this shape right here. We have this shape right here. And then we still also have this outside shape as well too. So we need to have something that kind of closes off and puts a barrier in between them. So we're just going to make sure that we're not just going straight up, because if we go straight up, then we lose the edge flow around this right here. So instead, we're just going to go just off to the side. Probably add another one right here. Now we did that. We can kind of start seeing where we can start going from here. We go up, straight up. And actually, I'm going to do that the opposite way. I'm going to grab these and then hold shift and bring that up. And just kind of copy the angles right here. And then edge. And I'm just going to get this kind of quickly going, because we're going to keep on hitting over edge flow over and over again throughout the day. All right, so here's another thinker. Why have I only like really gave a crap about one side? What? I can copy paste it. I can do other things that can quickly take whatever half my work is and double it over. That's the thing. That's also part of pre-planning, looking for areas of symmetry where you can cut your work in half. Because it's not us trying to sound lazy. It's not like, oh man, I only want to do half the work. That means if you can do half the work, that means you can do a lot more work on one side and then have a more fleshed out model. So, with that said, and we'll show this repeatedly throughout the lecture, but what I'm going to do is just go right here, delete half, because we only need half. And then from there, I'm going to make sure that all the verts in the center are lining up. Can anybody think of a quick way that I could probably get these all lined up straight? What? V, actually X, exactly. X, we can use that and very quickly snap it. There's also another way that can do it as well too. What? We can mirror, but it's going to keep that gap. So if they're like slightly off, then we're going to have a gap in between the pieces. So going back to the whole idea of like the cylinder, like we want it to be flat. Somebody said scaling. What happens if we keep on scaling it down? Scale the X, exactly. So if we go right here and scale, you can only scale down until it hits 0. When we hit 0, that means that everything I have selected is flat. So that is a quick way. Also, I accidentally, for some reason, deleted that. So let's go ahead and fix that real quick. All right, now let's do our Maya Voodoo and flip this over. So we can do that by having it selected. Keep in mind, you're probably wondering, like, anybody kind of like having like a little mini freak out that my wireframe's red and yours not? All right, just making sure. I changed mine to be red just so y'all can see it a little bit better. I don't know if y'all can see that a little bit better, but it sticks out a little bit more. That is something that I did on my end. It's not going to affect y'all whatsoever. All right, with that said, I'm gonna hold down Shift right click with that selected. And I'm gonna go to mirror. Inside of here, and we'll go through these options a little bit more when we get into combining two different pieces. We need to tell it what we're mirroring across. So right here, usually I go with bounding. And then now it's asking us which direction to go. So right now it's Z, so that's Z for us right there. Instead, we need to look at our compass and see which side we need to flip it to. We see that that's X, X. So we hit X, and now we are good. But here's the thing, it's doing something that I don't like, all right? It's not doing what I want it to. I'm not going to really explain what it's doing wrong, but I want to explain with, hey, if it's not doing what we want it to do, every tool that we use, if we go to that tool and hit the option box, it will bring up its options. And every tool has an edit and reset. This will take it back to default. Almost every tool that we use in our video tutorials are set to default, unless they're not, which is you will actually see us go into the options and do it on the video. Those are the only times that those tools are not default. So if your tool does not do something that the video shows you, make sure that you go into the option box. So mirror the option box, and then go to edit, and then reset. That will reset that tool to default. And the reason why I'm resetting it is because by default, mirror will make that into one object. Right now, it's still two separate objects, and that's why I'm resetting it. So, and then right here, delete, and then we'll just repeat that same process. So mirror, and likewise, if I hit Shift right click, hit the option box. Yeah, this is what scares people a lot about like the mirror tool. It'll turn your stuff into like weird, crazy Christmas ornaments. But the thing is, it's the options, and we can play around with the options right here. So the first one I always look at is access position. I usually go with bounding box, because bounding box usually looks at where your object ends. So it doesn't go off a local or global or anything like that, which we'll talk about a little bit later. It just looks at where my object stops being that object, and then it just tries to add it onto the other end. Next is axis. We just look at our compass and see which way we want to flip it. And then we have to tell it which direction. So going back to geometry, when you made the graphs, you had the negative side, you have a positive side for each one of your axes. Same way here. We just need to flip it to the positive. Oh, wait. And then we have one last thing that we have to do, which is our merge threshold. How far it's going to grab verts and try to merge them down to the center. This is the one that people get wrong the most. We only want our verts to merge at the center. So can anybody think of what number we can put in there to make sure that only the verts at the center merge? 0, it'll just not do anything. But somebody just said it. 0.001 or something like that. Something very small that still has value. Remember, 0 has no value, but we need to have some kind of range. So we put 0.001, and essentially all that's saying is do not merge anything unless it's literally on top of itself. And going back to how we made sure all those verts were in the center, that's why. So that way when we mirrored it over, all the verts at the center are lined up on top of each other, and then we can just hit that merge. Bam, we're done. And then lastly, before we get, we call it quits on edge flow for this portion right here, we do need to add a few more things. One, obviously, we need to cap this off. Can anybody think of a way that I can cap that off? What? Extrude? Yeah, we can extrude. So we'll extrude in. And I'll probably do a few. So we got that one right there. And then we can just kind of go right here with the edges selected, and we can just tell it to merge. Just go right here, shift right click, merge edges to the center. And we got that capped off. And then the last thing that we need to do is we need an edge loop that goes around the outside as well too. So going back to like how we made sure that we planned out all our edge loops. So since we planned out our edge loops, logically now, where if I was to click on this edge right here with my insert edge loop tool, where would it go around? Let me go back to red so y'all can actually see what's going on. And then move this out of the way. So if I was to take my insert edge loop tool and click on this, where would it go around? Yeah, it would go around that cutout, which is logically, it makes sense to us right there. Like it literally is like a racetrack around that detail. Same way, if I go right here and click on this, it's the same thing. It goes around the detail that I set it up to do. And that's where that predictability is important. So right here, as I click, it's tracing around that detail. Same way it's tracing around there. But then the last thing that we need is one that goes all the way around. How do we quickly add that edge loop that goes all the way around? Extrude. Because again, we need more surface. We need that surface that actually has that track around it. So that's a case for extrude. So I'm gonna go right here, extrude, and just kind of pull it out. And now I have my edge flow that works all the way around my object. So, like I said, this is not going to make you a master edge flow, but hopefully it's getting you to start thinking about like, hey, I need to put an edge around this detail. I need to plan this out. I can't just throw in a whole bunch of edges and start yanking stuff around. I have to pre-plan everything that I need to do. What's up? How do I select only the edge for the extrude? If I go right here, I went and clicked, double clicked on the edge, and it went all the way around. Since I set up my edge flow, that allows me to quickly select all the edges on the outside. And then I just hit extrude, and then I just pull out right there. Any questions about that? I was hoping for something. Like this is a very complex thought process right here. This is where modeling exists, is planning out your edge flow and making sure that it wraps around detail. What's up? How do I select a certain range? That's a good question right there. So let's say I want to select from this edge to this edge. All I need to do is select this edge, hold down shift, and double click the edge that I want it to go to. So select one edge, hold down shift, double click on the one that you want to go to. Now, most of the time it will do that right there, but realize that it goes off of what is the shortest path. So if for some reason, like let's say I want to select this edge all the way around to this edge right here, that's not going to work because it's going to go with the smallest selection. Any other questions? All right, so that right there sets the stage for edge flow. Now we can start talking about how we start breaking in different details. So let's go back to the coil. I'm gonna go right here, save this as, I don't know, edge flow 001, hit save as. All right, so file, open. All right, so hopefully this is about the stage that you're at with your block out right here. This is what I would say your primary form is done at this point. A couple things that you may have noticed. One, we don't have all the pieces there. Why don't I have another wing nut on the other side? Yeah, it's not done. So yeah, like I can duplicate it later once I get completely done with it. That right there, I have to add in holds, I have to add in thickness, I have to make sure that I go and do the polishing parts, and then also make sure that I have the geometry clean. So I don't need that second one there until I'm completely done. Same way with anything that has duplicates. So with that said, let's kind of go through some of the harder details that we're going to be talking about today, which is one of the first things that you're always going to learn for, this is almost like the hello world of like modeling, which is punching a hole into something. How do we approach that? So let's kind of go through the concept right here. So I'm going to make a plane. Put that off to the side. I'm going to make this one by one. Make this a little bit bigger. And I'm just going to get something that I can use as a template so I can have, you know, reference for a hole. So I'm just going to go right here to create and just forget this part for now. But I'm going to grab a NURB circle. Mostly just so I have a circle to kind of like base my modeling off of. And I hit 5 on the keyboard. All right, and let me get rid of the grid. Don't need the grid right now. Show and grid. Likewise, we can also go right here. See that little blue button right there that has what looks like a grid on it? It's our grid. We can click that off. All right, so when it comes to putting a hole in there, one thing that you have to realize is the limitations of polygons. For every change in our surface, there needs to be a vertex and an edge. I can't just magically make a hole there. There has to be something that holds it because, again, everything goes off the smallest in the hierarchy. So for us to have an edge, we need to have vertexes. For us to have a face, we need to have edges that are held up by vertexes, which means if we want to hold there, then we need to start cutting up our geometry, which when we cut up, that means we add more geometry. So to approach this with a hole, what we need to do is first go with the multi-cut, or you can also use insert edge loop tool if you want. But I like to use multi-cut. Can anybody think of why I like to use multi-cut? What? More precision. That's one. You're in the back. Goes all the way through the object, and that's close, which is, it's a personal preference of mine. But like right now, instead of using the multi-cut and then hopping back to the insert edge loop tool, remember the multi-cut is actually 3 different tools. So it saves me time having to bounce between several different things. So again, if I want to use it as an insert edge loop tool, what do I hold down on the multi-cut? So if I want to do an insert edge loop on the multi-cut, What do I hold down? What key? Control, exactly. And that'll allow me to pretty much do the job of the insert edge loop tool. All right, so with that said, what we need to do is mark out where our hole is. All right, so what does that mean? We need to put like a edge above it, an edge to the side of it, an edge at the bottom of it, and then an edge to the other side. So what does that look like? Well, one, we don't want to put it right there. We want to give a little bit of breathing room. So instead we give a little bit of space, and then we'll mark the left, then we'll mark the right, and then we'll mark the top, and then we'll mark the bottom. All right, so now we have this sectioned off. Then lastly, we need to have an edge going through the center vertically, and then an edge through the center horizontally. Now, is this the only way that you can do a hole? No, we can actually make more complex holes and stuff like that, but this is the bare minimum right here. This is the easiest way to get a basic form in there. What's up? Hopefully we have enough, and we'll actually show this on the bracket in a second. It depends on how round you want your hole. So the more faces, the rounder we have, but also more faces, more verts to worry about, more complexity, and it just always comes down to your skill level. All right, if you're comfortable adding more, do it. If you're not, just kind of keep it kind of like bare bones for that period until you get comfortable enough to actually start adding more and more geometry. All right, so now we got that marked out. Now, how do we go about doing that hole? So going back to the whole idea, I did not mean to do that. All right. So if we wanted to make a hole really, really quick, we could just literally go right here, select all our corner verts like so, and start scaling them in. And that will start actually making an 8-sided cylinder top right there, which is to make a very nice hole. So if we go right here, I delete that. That's what my hole looks like. Very quickly, I can grab those verts from the corner, scale them in. Can anybody tell me why I wouldn't want to do that? We just talked about for 45 minutes. Edge flow, exactly. That right there, that's what we were talking about, that grid-based modeling. All right, we're just throwing a whole bunch of edges in there and then grabbing the verts and then hoping that we make that shape. And the problem is that now, if I need to add some more definition to that hole, none of my tools will go around it. And then anything that I want to like work with over here, it messes up those edge loops as well too. So going back to how we were talking about those contours where like different shapes were meeting up with each other and where we had to start creating barriers. That's what we're talking about here as well too. We already have like our nice flat area that looks neat. We need to preserve that. But then we also need to make sure that we put a fence around where we're going to have that hole. So what would probably make, how would I go about making that fence? What? Yes, exactly. So if I go right here, grab those faces that make up that, I can extrude that in, which preserves that barrier outside and the barrier on the inside right here. And as I extrude, you're kind of noticing already, it's creating that racetrack around my circle. And now I can just extrude in. And now I can grab every other vert, scale that. So now when I start trying to use my insert edge look tool, and then eventually the main reason why we're setting up this edge flow, which is the bevel tool, which we'll show a little bit later, it works perfectly. So right now, if I need to add another edge loop right here, it's going straight across. It's not being affected by this. Same way, if I need to add an edge loop right here, it's not getting all janky. So we have to have that barrier, that fence, to kind of keep those separated. We don't want them to influence each other. That is very important. A lot of times when people start trying to make these holes, they'll start jacking up their geometry because they forgot to add that barrier or extrude in. Any questions about that? All right, so I think we have somebody talking about, I think on day one, I think it was you. You were like using 2017 or something like that, or like an old version of Maya. We'll occasionally get that where people are just like, hey, I have my trusted 2010 version of Maya, or I have Maya 8.5 back when, like, you know, they didn't actually have years. They just kind of named the versions. Why do I need to advance? Why do I have to update? Well, this is how we used to make holes. Now we have a button that just does it for us. So if I go right here, if I grab, let's say, these four faces right here and extrude in to create my barrier, because again, you still have to do that. With those four faces selected, I can hold down Shift, right click, and go down to something called Circleize Component. And bam, it will go ahead and make that into a round surface for me. That is something that did not happen until 2017, all right? That's why it's always good, one, to update Maya, and two, keep it updated, because some of these tools actually happen in update releases of that version. Like when we get into UVs, UV Toolkit, that didn't really actually become a usable thing until I think 2018.4 or something like that. So they'll actually add features when they're actually updating it. Now, yes, that made my life a little bit easier, but that wasn't that hard to do. But going back to what you were saying, we could add more edges in there and make for rounder holes. So instead of just grabbing 4, let's say, oh no, that looks like 16. I do the same thing, extrude that in, and then hit Circleize Component, and now I have a much rounder hole. Hit delete. So it's always good to know the old school way of doing it, which is the bare minimum, take 4 faces, extrude them in, and then just grab every other corner vert and scale those in. Very quickly, you can knock out, like, you know, a decent hole. And once we actually do the next process, it looks pretty good. Or we can go into a little bit more high poly modeling and still have it be not too complicated. But everything that we've done so far has been on something that's flat. How do we approach putting a hole into our bracket? Before we go into that, any questions? All right, so that tool, again, is called Circleize Component. Just, you can either select faces or edges, and then shift right click, and you should see Circleize Component. Go right here, hit delete, delete, and let's actually work on our thing. So, go right here. And let's focus on doing that hole right there. All right, so first thing is I kind of want to just focus on that one hole. All right, I don't want to focus on, like, you know, the fact that there's a coil there, there's like a couple other pieces that are kind of blocking my vision. So let me go ahead and select the piece that I want to stay. And I'm gonna go also and hold down Shift and select the image. And then I'm going to hit Control 1. That way it hides everything except for what I have selected. So again, select what you want to stay, and then Control 1. How's everybody doing? Yeah, yes, no. All right. Again, if you have questions, let me know. Okay. All right, so got my hole here. How do I need to approach this? What should I do? Ariana. Oh, go ahead. We got a volunteer. Okay, walk me through how we do before. We don't have to create a texture. I just brought that circle in so we could just have a circle to visualize. All right, so if we skip to the next step, what did I have to do first? Close. You're missing a few steps at the beginning. What's up? Close. We selected the 4 faces, but what did we do before then to actually get the 4 faces? We multi-cut, but where do we put our edges? So we remember, we have to section off the hole first, which means where we put edges around the hole. So we go one at the top, one at the bottom, one at the left, and one at the right. So technically, we already have one right here, but we do need one right here and one right here. So I'm going to cut that one in, that one in. So now we have one above the hole, one below the hole, one to the left, and one to the right. So remember, we're just cutting out and putting a fence around that hole. The next stage is we need to have one edge going through the center vertically, and then one through the center horizontally. So essentially, what you were saying, the 4 faces around that hole, we have to build that first. If it doesn't already exist, we have to make sure that we have those 4 faces to begin with. All right. Now, as you can see, my 4 faces are nowhere lining up with that hole. But here's the thing. I know that that hole in that picture is wrong. I know it's pointed slightly off to the side, mostly because how we arranged it and took pictures of it. So instead of trying to follow this to the T, I'm just going to observe that, like, hey, I know that's going to be in the center, and I'm going to make sure that I'm not distorting my model to match the distortion on a picture. All right, that's what you always have to kind of take a step back and go like, all right, I know that this reference, it's not displaying completely correct. So as an artist, as a modeler, I'm going to have to make that adjustment on my own. All right, so this is already marked out on the center of my bracket. I know that hole's already in the center of the bracket. And here's the thing, we can already see like there's distortion right here. You can even like look right here. See, this doesn't magically get like wider in the back right there. It's completely straight. Meanwhile, if we look right here, the front's straight, and then for some reason it like jumps up right here. That's just because of how the angle of the image is. So we have to take a look back and not take our images completely 100% for fact. What hotkey am I hitting right here? Spacebar, okay. So now that I got my 4 faces right here, what do I need to do? Extrude. Why do I extrude? So I can make that barrier. I want to make sure that I'm not changing or affecting the shape that's already outside there, and I don't want that outside shape to affect my hole. So I extrude in, and then now what do I do? Shift right click and circleize. Exactly. Now, so far this tool has been working pretty well for me. Most because, like, again, I hate saying this because it always sounds like I'm tooting my own horn, but I make this coil like almost every month, all right? So, like, these tools work perfectly on good geometry. It may not work the same way with you, all right? If it doesn't, that's okay. You can always Z back, make a correction, or two, play around with the options. The main thing is, don't completely shut down or freak out if something is not going 100% one-to-one with what you're doing. So with this right here, we're getting a little bit of a weird angle. So we can play around with our twist, which will turn this, and we're trying to line this up. We're seeing that this is a little wonky right here. So I'm just going to move that to where this straightens up, and that looks good enough. And we got our hole. How do I make this a hole? Yes, delete the faces. Exactly. So we go right here, delete those faces. Now we're running into one more issue, which is, one, I accidentally deleted faces in the back. So always triple and double check your stuff. So hit Z. How can I quickly deselect this? How can I quickly deselect this? Control and then marquee select. Yep. And now only that's there. Hit delete. All right, so I'm gonna hit Control 1 to kind of bring that up. And as we can see, this is causing some slight dents. And actually, I'll just go right here. To make it a little bit more obvious, I'm gonna just kind of grab this, hold down Shift right click, go to soften edges so we can get rid of that weird wonkiness. But if we look right here, we're getting some weird shading right here. That's because our hole is not lining up with the curvature of our bracket. Every tool that Maya looks like it has like this miracle tool that does a lot of work for us, we still have to go back and make adjustments. It'll get us hopefully 85, 90% there. Sometimes it doesn't. But this right here gives a hole. That's nice enough. Now we need to go back and kind of tweak out and make sure that that hole is going along with the curvature. So if I want to make sure that this hole is staying with the roundness of this curvature, what view should I look at? What? Side view? Okay, let's kind of look right here. So it's a little hard to see right there. Any other view? What? Exactly, top view. Because if I select this right here, Control 1, we can start seeing where it's starting to get off of that curvature. So right here, we can already see our curvature right there. And then we can start seeing where our hole is not matching that. So we just go right here and just start moving it back into place. And just tweak it out. All right, that looks good enough. Yep, that looks fun. All right, so now we got a hole in there. How many holes is in this bracket? So one in the front and two in the back, right? What? Yes. So There is also one right here, so we can do that same process. So very quickly, we can just kind of go add that in. So repeat the same process. So, and then shift right click, circleize, we got that hole. And we can play around with the twist to make sure that that's lining up a little bit better. But then we can delete that. Repeat that same process and get that same hole over there. And believe it is me, then I also realize that there is also a hole right there as well too. I don't always go looking for that hole. I make sure that like that hole's over there. But, and the whole idea of like preaching, make sure that you actually are staying accurate with your modeling. Be aware of all the different details, all right? Make sure that you try to achieve all of them. And by which I mean, if I go right here, and class files, RDF, wrong place, and then the coil, and then we look at this one. And there's that mysterious fourth hole. Yeah, 4. All right. So just to make sure you're aware of that. But another thing that hopefully you're kind of seeing me do, which is going back to that pro tip I told you. Does this have any thickness? No, it's flat. All right. So going back to like when I was talking about like when we were modeling stuff, especially anything that has any thickness, we want to model it with no thickness whatsoever, because we can always add that in later. And that's very important to do that before we start doing holes. Because to add thickness, all we need to do is go into face mode, select all our faces, and then hold down shift, right click, and extrude. And then we just grab this blue arrow and pull out. And now that will give us thickness. But then it also does another thing for us as well too. It translates that detail that we add onto it to both sides. If we try to wait until after thickness to add this hole, what would we have to do? Yeah, line up. We would have to put a hole in the front, put a hole in the back, and then create the surface in between, and then make sure that it all lines up. That's like 4, 5, 6 different steps that we didn't need to take, all right? So that is a key part. If you can model it flat, and then add thickness later. It will save you a lot of time. Any questions about that? All right, so we got our bracket there. Grant, again, make sure that you're going to the secondary forms section. That will take you step by step on how to approach this, because if you haven't noticed, I didn't put in that 4th hole or the 3rd hole, nor did I actually do like the little cuts right here. All stuff that I would have done before I added thickness. Now, next stage. All right, so next thing that we're going to go over is how to actually before we move on to the next stage, any questions? I know like what that was like about 30 minutes, just me saying hole over and over again. Any questions about that? The main things that you should be taking away from this is 1, how we approach a hole, why we put edges around it, and the idea of like how we transition that idea of edge flow into the hole. And the idea is that we have these details and we have to keep them separated. All right. If we don't, then our tools become unpredictable, and then it will actually make weird rendering issues, lighting issues. It could mess up rigging. It could mess up animation, things like that. So we have to make sure that we are purposely doing stuff. That's what makes us professionals. Everything that we do has purpose. All right. So next thing that we're going to go over is approaching an object by using multiple shapes to make it. All right, so how many people have kind of looked a little bit closer at this blacktop? No hands. All right, cool. This is a coil, guys. This has this blacktop. I don't know the technical name for it, but we gotta model it. So here's the thing. If we look at it pretty close, we not only see like, you know, the basic primary form that we modeled, which is kind of like that little nozzle look, but we also have like this weird like platform that comes out. All right. So logically, yeah, we can go in there and we can cut up some areas, we can extrude some stuff out, start building this off of here. Or going back to primitives, we can kind of look at like our object in different primary forms. So we had this right here, which was a cylinder, but then we have this boxy shape right here. So why, instead of trying to pound a new shape out of an object that doesn't really fit it, instead take another object, make that form, and then start merging them together. All right, that's where we get into complex modeling. So let's go ahead, grab this nozzle, hit Control 1. So we got this part right here. Go ahead and delete that for the time being. Don't know why all these are here, because they add nothing to my shape just yet. All right. So that's closer to my shape. What's another thing I should do? Save, yes. So again, how many people have been setting timers? Got like an egg timer or a watch timer or something like that. Something to a roommate that's really nice to come check on you every like 15 minutes. Anything like that? I can't kid you not. You got to figure out some way to remind you to save. Because you would think like losing your stuff crashing and you losing work would be enough to kind of drill that in, but no, it's a process that just takes years of being hurt to kind of get that like knocked in. As you even notice right here, I forget to save. But the fact is that, again, remember, there's nothing that we can do to recover your stuff. We can't make it come back from the grave. We can't make it do anything. We can only just listen to you cry. All right. The fact is that that's one of the #1 things that we get here about on the day of the turn-in, is that like, hey, this crashed, we lost everything, I don't know what to do. All we can say is sorry. There's nothing that we can do either. So do whatever you can, make sure that you cover your butts and that you're having a plan B, you have other stuff to kind of work on if that crashes. All right, with that said, let's kind of get in here. Save as, and I'm on secondary form, so I'm going to do secondary form 001. All right, save as. Hit continue, and then we're gonna go right here, creates. We're gonna make a cube, because like I said, that platform has a boxy shape. And since I kind of already know what it looks like, I'm gonna quickly kind of model that. Put one right there. And then I'm gonna bring this out. All right, so I got my platform right there. Again, the video is gonna show you how to go through that step by step, but the process of this right here is mostly about how we get these to merge together. So first off, I need to move this to where the black top is. What's a good way to do that? What? I can just yank it up there, right? Or is there a faster way? Snapping, exactly. So I'm gonna go right here, hold down D as in dog, V as in Victor, and snap to this bottom one right here. I obviously know it's going to hit somewhere over here, but I need to make sure where my verts are, so I need to go to shading. Wireframe on shaded. And then I'm gonna hold down V and middle mouse click and drag right there. Now I need to get this to the proper size. So I'm going to scale this down. And then try to match that up a little bit right there. Bless you. All right, and there's my platform. I'm done. Pay me money. All right. The fact is that now we kind of have this blocked out. Same way, the same concept. We are building this. So this is almost like a primary form stage. So we need to make sure that we're getting the proportion and scale right before we start integrating them together, because integrating them together requires more geometry. More geometry, more problems. So from there, one of the things I like to do is I like to kind of get these to where they're touching. So I'm just going to go right here, just move this down to where like they're meeting up. You don't have to do this. I find that it's better to do it when you're starting out, because then you get an idea of where you need to start placing more geometry. I'm also going to make this a little bit smaller. There we go. Something close. It's close enough. I don't want to slam them through because I don't want to have to go search for that vert again. So just close enough. All right. So this is kind of just the sketching out, the planning out phase. Now, this is where we need to kind of start looking at both objects as a whole, because that's essentially what we're going to be doing, is actually combining these together and merging them together. Now, before I even go into that process, can anybody think of what we need to do before we start merging stuff together? Of everything that we know about polygons, the different modes of polygons, what do we need to have? So like, let's say I have that vert right there. What needs to be there on the other object? An edge, all right? So again, polygons, there has to be a vert for something to connect up. And for that vert to be there, there has to be an edge, all right? So think of this right here. For every vert, there has to be a vert. For every edge, there has to be an edge. So we need to start putting edges in here to support where this would meet up. So one of the first things I'm going to do is probably add an edge loop right here. Why would I add an edge loop right there? Protect my edge. Exactly. We're changing direction. We are changing detail. We're adding more stuff in. So we need to make sure that we preserve what's already there. All right. So now we're going to go right here. And I'm just going to, let's see. So it looks like there's going to be an edge right there. That's fine right there. So kind of already have a barrier for where this meets up. I'm going to put another barrier right there. And then what I like to do is I'll just go ahead and get rid of the faces that this intersects with right there. So now I have a gap to implement this in. Can anybody think of any other faces I probably should get rid of? Delete them underneath. Underneath what? Exactly right here. So underneath this right here, we still have faces. Those can't exist. So when we model, the inside of our model needs to be empty, all right? Especially with something like that right there. If we have faces on the inside when it's completely closed in surface, that leads to issues later on. So we need to make sure wherever they connect, there's no faces on the inside. I'll go right here. Probably scale that in a little bit more right there. All right, so what I typically do now is I just start going, all right, there's a vert there, there's a vert there, that'll match up. There's a vert there, there's a vert there, that'll match up. There's a vert there, there's not a vert there. So what do I need to do? I need to add it in. Yes, exactly. Vert there, we're good. Vert there, anything there? Nope. So we need to add that in. Vert there, we're good. Vert there, and vert there, we're good. Vert, 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 vert. All right, we're good. So that's part of our pre-planning. Now we have to tell Maya that this is now one piece. All right. We can't just start actually using tools that are on one object on two pieces. We have to tell Maya, hey, now these are going to be considered one piece. So to do that, first, I'm going to save because it's been 15 minutes. And also that's a drastic change. So that should be also another consideration before I start doing that. All right, so now for me to consider this one piece, I'm going to select this object and then hold down Shift, select the other one that I want to combine together, and then I'm going to go to right here, Mesh, Combine. Now Maya considers this one object. How's everybody doing on that? All right, so again, going through this whole entire staging so far is that one, we did like the primary form process. We made the basic shapes. We got them the right sizes. We got them in place. And then we went back and made sure that we planned out our edge flow. So one, making sure that we preserve. Oh, I thought somebody was talking like weird voice. All right. Anyway, so we made sure that we planned out our edge flow, which is one, make sure that we were preserving the detail that's already there. Two, making sure that there's a vert for every vert. And then three, we actually went and told it that it's one piece. So we can use a brand new tool. And this tool is called Mesh Tools, Append to Polygon. And what this allows us to do is click on edges and actually build polygons between them. So as I click one edge, we will see it actually highlight that, and then we'll get like this weird little purple outline. What those edges are considered are border edges. Border edges is pretty much an edge that's on a face that doesn't have a face on the other side. All right. So like literally that's where our surface ends. That's what a border edge is. So we can click from one border edge to the other and build a face in between it. And then we repeat that same process all the way around. And this tool can only be used on an object that is one piece. That's why we have to combine it. I want to bring that tool back up again. So what is a quick hotkey I can do to bring up the same tool again? G, exactly. Enter and just repeat. G. G. So mesh tool, append the polygon tool. All right. So am I good? What? I think I heard somebody start saying it. So again, I could keep on using that tool all the way around, but what's going on here? We have areas of symmetry. Yeah, exactly. So So far we've been cutting stuff in half and flipping over, right? Remember, this has 4 areas of like symmetry, so we only have to do 1/4 of it. So I'm gonna just go right here, cut that in half. Make sure that I only got half. How do I get to my mirror tool? Shift right click, yep, and then mirror. And I hit the option box, so I'll know I should go back and make sure that I hit mirror. And then what should I do? Yes, change the axis position to bounding box. Exactly. All right, so now I get that. Where do I need to go now? Yes, change the axis to Z. Again, we're just going to look at where our compass is and where we need to flip it across. So like we need to go in the Z direction. All right, what now? Yep, so yep, we need to change direction. So right now it's at the negative. There's only 2 options, so we just switch it to the other one right there. And then the last one, which is right now we're not getting any issues, but to be safe, what should we also change? Yes, our merge threshold to 0.001. That is the process that you want to use the mirror tool. You want to go step by step. 1, change the axis position. I like bounding box because, again, it just looks at where your object ends. That may not always be the perfect case, but usually by then when you need that, you'll actually have a little bit more experience with modeling and you'll know when to use that. Mostly when you need to change that up is if I have a bracelet on this arm and then I want to copy that bracelet to the opposite side onto this arm and it's in the same position. That's where I would probably change to like, world mode or object mode. But for right now, everything that we're doing is meeting at the center and I want it to actually touch. Next is axis. Right there, that's just making sure that we're flipping it to the right side. And then lastly is direction, which is to make sure that it goes to the right side of that axis. And then always be safe than sorry, set the merge threshold to 0.001. Always go through that process, no matter what. Like I said, we weren't getting issues with the merge, but it was better safe than sorry to actually go and set that up. And then we'll cut that right there in half. And then do the same thing. Mirror. Nothing happened. So we'll try that again. All right, same thing. Bounding box. Axis is X, so that's looking right. Negative, that's looking right. And then just to be safe, 0.001. And boom, we did 1/4 of our object, and then very quickly we were able to turn it into the rest. That's one of the things that makes modelers great, which is if you can plan like 4 or 5 steps ahead, then it makes your life easier. Always be thinking ahead. Any questions about that? You got a question? Anybody? No? Okie dokie. All right, so that's us actually building object out of multiple pieces into one object. Next thing that we're gonna have to do, which is everything that I've been saying, wraps into the next part right here, which is something called edge quality. Believe it or not, how you do your edges on your objects is a quick way to make something either look like it's real or it looks very, very CG. All right, look at everything in front of you. Run your hands across it. Fill things. All right. Does everything have like a 90-degree edge or a knife fill or anything like that? No, everything has like a little bit of roundness. That's the thing. when we see these super sharp edges on our objects, it makes it look CG, because that can only happen in a CG environment. Like our cubes, when we make them that have those nice 90-degree angles that are perfect, they look CG because it is. That's computer generated right there. We have to go back and add those imperfections, those roundness, those areas where we get those little different degrees of roundness and sharpness. All right, that's where we get into beveling. So what does that mean? So let's kind of go right here and talk about a couple things. Mostly because we get people in here who've already been using a certain mode to model in, and we have to break you of that habit. So I'm gonna go right here and kind of go through some of that. So we're gonna hit create. I'm gonna make a couple of these right here. Then I'll make a couple of these right here. And let me do my edge quality spill. All right, so there is two ways that we actually represent stuff right there. All right, so trying to think the best way to approach this. So let me name off some terms for y'all to see if anybody's ever heard of them. How many people have ever heard of beveling? All right. How many people have heard of holding edges? All right. How many people have hit the 3 key on their keyboard? All right. So let's hit up all those different areas. So first off, let's talk about what 3 mode is. 1, please do not really use that too much. All right. The best way I can say, use 3 mode. That's a great way to kind of get an idea of what you're maybe rendering at the end. It's that little area of polish that makes our stuff look good, but you should never model with it. You should never leave your model in it when you save, because the fact is that if you haven't yet, right now what we're doing right here, this is our true object. That's what it really is. Every vert that we made is physically there. It's accurately displaying 1-to-1. When we hit 3 on our keyboard, essentially what that does is actually give us an approximation of what it would look like if we were to polygon smooth our object twice. What polygon smooth is that when I take an object right here, hit 1 to bring it back. When we smooth an object, we quadruple the amount of geometry that is there, and then we average in between it. So literally we add more geometry, and then we start averaging the verts, which gives us a rounder shape. When we do a smooth approximation, which is the 3 key, it does that twice. Which for some people, what makes their models look really nice. A lot of people get addicted to going into the 3 key too much, right? The thing is that the 3 key is pretty much beer goggles for your model. I can't stress that enough. It will make your model look better than it really is. But the thing is that you're not modeling it. Maya is. And 1, it can make your silhouette look bad because we always check your stuff from res 1. Next is, again, it's Maya modeling it. Think of it this way. If Maya's modeling it, why should I pay you? Instead of paying you, I'll just buy a couple more copies of Maya. That's why we need to make sure that we are modeling and doing everything purposely. Next is, does anybody notice the difference in shapes between like my cube, that's what it actually is, and then when I hit 3? What? Yeah, it becomes a Rocket League ball, but the fact is it becomes a sphere. It's not a cube. That's not my cube, all right? So that's another thing that happens is when we hit 3, we lose that definition unless we actually put something in there to hold it. That's where we get into holding edges. What is a holding edge? Yes. So it is literally an edge loop near the edge that holds that. So again, going back to that, what smoothing does, it adds quadruples our geometry and starts averaging it. So if we put edges closer to each other, that means that average is going to be smaller. So if I hit 3, the areas that doesn't have like an edge loop really close to it, they get changed more drastically. Meanwhile, the areas that I put a holding edge next to it, those don't get averaged as much. So they are essentially edges that are holding that shape. With that said, going back to 1, please do not model in Res 3. Now, I will show you a reason why you may want to go in Res 3 every now and then when we get into a problem geometry. But for the most part, stay in Res 1. That's how you're getting graded. 2, you don't want to use holding edges. Holding edges does have its place. We mostly do use it on more complex objects that we've already put in a ton of edge flow and a lot of geometry. Instead, what we want to do is something called beveling. Because right now, what we're seeing right here is a form of edge quality. We're not getting these nice 90-degree angles right here. We're actually getting this nice little round off. So that would be something closer to what our table is right here. If we run our finger across the table, we have this little bit of roundness to it, all right? That's important because when we light things, how light bounces off of objects and catches the rim of it makes it believable. And whether or not like we hit that roundness is important because if we go too sharp, it looks CG. If we make it too round, then our table starts looking like a Fisher-Price toy, all right? All these little things makes our object believable. So what we want you to do instead is something called beveling, which some of y'all may have heard about this through a 3D product, or some of y'all may have heard it through how many people had shop class or did any kind of carpentry or anything like that. A lot of our terms come from carpentry. So when we bevel an object, what we do is we'll select our edges and then hold down Shift right click, and then we will see a bevel tool. And what this does is pretty much adds an edge loops around our objects, but then we can go right here and start adding in more segments, and we'll automatically go ahead and add in that roundness. We can actually play around with that roundness as well too. But the fact is that we're getting that roundness without having to hop into Res 3. That's Res 1 right there. We're seeing that, and that's our actual model. That's something that we did, that we can control. And then from there, we just gotta pay attention to how round our subject is. So if we look right here, if we look at the top of that bracket, that's gonna be a little bit sharper. So 1, we need to play around with our fraction. Our fraction is how far apart these edges are from each other. So if I select fraction, I can go out into my viewport and middle mouse click and drag to control it. Anywhere that I select a name, I can middle mouse click and drag and turn that into a virtual slider. Likewise, if I hold down control, I can just kind of fine tune that. So I'm just going left and right. And what I'm trying to do is just get an edge that looks like that. But I have to be careful. Again, that makes it look like a Fisher-Price toy. Definitely that makes it look like a Fisher-Price toy. But if I go too close to each other, then it becomes pointless that I even bevel to begin with. So we have to make sure that we are accurately modeling the edges of our objects. So the next thing is our segments, which is how many edges that it puts in there to make that roundness. And that's another thing that we have to play around with. Too few, we make more hard edges. Like right there, it just looks like I just took a power sander and just power sanded off all my edges. Too many, that's just insane, all right? Because especially if I'm viewing it from this angle, that's just too much. So we have to actually just kind of play around with that. Good rule of thumb is if we're going to have something that tight, especially this early on in your degree program, I usually stick with like 2 or 3. Once we start getting like, if we need to go wider, then you just start adding in enough to get what you need. Any questions on that? What? Depth? Think depth, and I never really play around with it. You can play around with the fact that it either concaves out, convexes out, or concaves in. We can always all test that by going right here, hit T, and we can just kind of drag that around and see what it does. Worst case scenario, what can we hit? Z, and go back. As long as you're saving, experiment. See what something does. The worst thing that can happen is you grab it, you pull it, it crashes. Well, you already saved. You just have to reopen it up, and now you know what happens. All right. Again, I can teach you only so much. Some of this will have to come from trial and error, which is important because a lot of our tools may seem like they only have one purpose, but sometimes you can break tools and use them as new modeling. So if we go back to right here, you probably already noticed that I had like a little bit of curvature right here already on my bracket. But I didn't actually put in that curvature. I just kind of grabbed the edge and I used bevel. Bevel's not actually there to like really add that curvature in, but I'm using a tool, since I know the results, I can kind of break what it's supposed to be doing to kind of get in detail that I need. That's the thing. You can only get to that if you just experiment with your tools to see what they can do and see if you can kind of like, start blurring the edges of what they're actually capable of doing. Now, with that said, you do need to pay attention to what you're beveling, because a lot of people get in their head that like, hey, beveling is this make round tool. How many people believe that beveling is, hey, it just makes stuff round? How many people believe that? It's okay if you raise your hand, because like so far, everything I've shown you, hey, it just makes that edge round. The best way that I can say what bevel does is that it highlights the edge, or it accents the edge, because the thing with bevel, it can actually do the opposite if it's already round. So if we go right here and look at this cylinder, turn off wireframe unshaded, the side of the cylinder is already round, right? Already appears round, right? It's only this edge right here that is looking like it needs to be beveled. But if I grab the whole thing and hit bevel, now I get this round edge, but now the areas where I already had roundness, that's all looking jacked up. All right? So, bevel is not the make round tool. It's our edge quality tool. So we want to make sure that we're only using on edges that need it. Good sign of whether an edge needs it or not is it drastically changing direction? Does it need more definition? Those kind of things. So, unless your end result is you want to have a disco ball for some reason, you want to make sure that you never like bevel things that are already round. But unless you want to make a disco ball, you can go right here, add in our bevel, and bam, we got a disco ball. All right, any questions about beveling? T is, so pretty much every time that you see, and that's a good thing that you brought that up. All right, anytime that you see like a menu pop up when we were using a tool, how many people have like clicked off and go like, oh man, I need that menu to come back? All right, if you haven't yet, you will. To do that, all you have to do is select your object again and hit T, and it will bring that menu back up, the last used menu. All right, that way you can get to it. So T as in Tommy. All right, going to delete that. So if I was to approach this right here, where would I bevel? All right, so we got to be a little bit more specific with which edge. So we can only bevel edges. That's a good thing to bring up. So you have to bevel an edge. You can't bevel a face, you can't bevel a vert. So we need to look for the areas that we have a huge change in direction. So one, huge change. So we see that it goes this way and then we drop into a different direction. So we need to bevel that. Obviously something like that, we would need bevel. And again, we want to make sure that we are using both fractions and edges to kind of get the roundness that we need. We do have a kind of a steep change right here, so we could probably add in another bevel. As you can see, this could be also a case where we could break our bevel, which we could quickly add in like a little bit of curvature that it's not intended for, if need be. But for the most part, we need to have that tight change. Now we start getting to these areas right here. So we need to probably bevel all these edges so it actually holds that shape. So we need to go through and select all the edges that we probably want to bevel across. Probably that one too. Make sure that I got everything. And the reason for that is because if we have a lot of edges that are intersecting and meeting with each other, sometimes it's better to grab them all at the same time and hit bevel. That way it can figure out those junctions for us. Now we will still have to go back and double check to make sure that they did it right, but it makes for a little bit of a cleaner bevel. So go right here, bevel, and then we're just going to add a little bit of roundness to it. Oh, and I missed one. So same way with like extruding, you want to double check your work with beveling. So bevel, biggity boom. All right, that's looking good. Any questions about that? How's online doing? I haven't really heard anything from them. Okay. How's everybody doing here? Good. I know it's a lot of stuff. We're getting close to the end. Now, we went through edge flow. We went through cutting in a hole. We went through like making complex shape out of multiple objects. We went through the idea of edge quality. So main thing with edge quality, anything that has like a good change of direction, that needs a bevel, and that's across all our edge, objects. Bracket, the coil, the blue body, things like that. All those areas will need a bevel. Again, we don't have time to go through like every edge that needs it. Again, make sure that you're watching the walkthroughs. But this brings us into our last bit that we have to talk about, which is everything has been all happy-go-lucky, hopefully for everybody. We've just been creating. We've been making stuff. But the thing is now we're at the stage where we have to make sure that that stuff that we made is correct. It's built right. And that's where we get into problem geometry, right? Not everything is happy-go-lucky inside Maya. There is stuff that will break our tools, that will break the next part of our pipeline, that will stop productions dead in its tracks if it's there. And it is our job to make sure that we go back and correct that. So let's start going through that. So making the plane so I can describe all the different things that can be wrong with your stuff. All right, so first, Let's talk about like what can be wrong with our stuff and how it can happen. So there's several different things that can go wrong with our polygons. The number one thing is that first we observe a common workflow. So far everything that we've been building has been either a tri or a quad based workflow. Can anybody think of what that probably means? Tri-phase or quad-phase workflow? Yes. So either our shapes are either triangles or four-sided, which is a square or quad. For the most part, we actually do observe a quad-only workflow. I just have not been going back and cleaning up the triangles. I usually say that to the last step, and the walkthrough actually goes through that process as well too. But the thing is that we go over a quad-based workflow because that is the cleanest workflow that most render engines and most game engines observe. The reason for that is because at the end of the day, again, I'm pretty sure this marker doesn't work. Is it a hidden marker? All right. So here's the funny thing. At the end of the day, everything that you make when it's rendered, when it goes into a video game, becomes a triangle. It goes through a process called tessellation, which is weird. You would think like, all right, well, if it's going to become a triangle, why don't we just build everything out of triangle? Well, one, triangles don't really make for the best edge flow. All right, they kind of like spiral and do all kinds of crazy things like that. And two, if a engine is not really optimized, it will try to triangulate that triangle. And the only way that you can triangulate a triangle is to draw another edge, and that edge has to go somewhere. All right? Meanwhile, how do you triangulate a square or a rectangle? What? Yeah. That intersection is self-contained. All right? Doesn't create any new geometry, doesn't create any weird wonkiness or anything like that. Now, most engines these days and render engines these days, almost all of them, they don't have that issue with triangles. So we usually kind of get away with like having a few triangles. Your screw that you're going to be doing on the back of the coil, that's going to probably have a few triangles, just mostly because it's trying to make your life a little easier and it's not going to give you much of a headache. All right, but for the most part, we observe that principle right there of quads. That's where we get into the actual first case of problem geometry, which is something called a n-gon. Literally, the letter N hyphen gon. Can anybody guess what that means? Yes, it is literally a polygon with more than 4 faces. That N is a variable. So literally, if I have a face with like 9 sides, then that stands for a 9-sided gon. And the reason why that is an issue is, how do you triangulate a 9-sided n-gon? I bet I could draw it up here, and I could have 10 different students come up here, and they will do it 10 different ways. That's the same way with Maya. When Maya tries to do it for you, Maya doesn't care about your artwork, doesn't care about your edge flow, doesn't care about anything that you do. It will do whatever makes sense to Maya, which can end up with your stuff getting jacked up. That's the reason why we do a lot of stuff in cleaning up, is to make sure that Maya doesn't do it for us, because we worked hard to make sure that we have that definition, that edge flow, and that style. We don't want Maya screwing up at the 11th hour. So what does that all look like? Well, pretty much if I go right here and hit delete, now I just made an n-gon. I just deleted a bunch of edges, and we still have these edges right here intersecting into my object. That, even though it looks like, and let me go ahead and click off because that blue is really hard to see. Even though that looks like a square, there's still vertexes and edges there. So we have right now 1, 2, 3, 4, 5, 6, 7, 8, 9. Now that is a 9-sided face. So if Maya goes through and tries to triangulate that, it's just gonna go and, I don't know, do something that makes sense to it. right? So I'm guessing that's what it's going to do. The fact is that looks like shit, all right? And if that was happening on something like, let's say, a character's face or the side of a car, that's going to just make you look bad, all right? So that's where we have to go back and fix it up. And really, that's how we fix it. We go back, find that Ingon, and we quad it up, which is we'll draw edges in there to make it into where all those faces are four-sided faces. Where this happens the most, honestly, did anybody think it was weird at the beginning of lab when I was saying, hey, when we're making this cylinder flat, we grab those faces and we hit delete. And I'm only going to do it on faces. Anybody thought that was kind of like weird and out of place? Hopefully somebody did. The reason for that is because you would think logically, if I was to grab this edge and hit delete, I got rid of that edge, right? I should be fine. All these are like squares, right? I already heard somebody go, no. All right. Why would that be an issue? So I selected all those edges and I hit delete. Why would that be an issue? It could, but going back to like if it's a true quad, it just draws from one corner to one corner. That's the only way that you can quad up a quad. Exactly. When we hit delete on edges, it literally does that. It deletes the edges, but it doesn't get rid of the vertices. So if I go right here, go to vertex mode, bam, I have all of these. And the fact that that vertex there means that these are now two separate edges. So now I have 1, 2, 3, 4, 5, 6. This is the #1 reason why people have issues with Ingons. It's because they'll accidentally delete an edge using delete, and they'll leave those vertexes behind. The proper way, let's go right here. Select the edge, hold down shift right click, and hit delete edge. That will make sure that that edge disappears with the vertices. So that's the first one. The next one that we're gonna like talk about, next two are going to be really, honestly, two things that you're not gonna worry too much about. All right, they're there in the cleanup tool, but the fact is that they're not going to be that serious unless they're too extreme. All right, because technically you're still low poly modeling. So you have to kind of extend the boundaries of what a polygon can do. So the first one is something called the non-planar face. And non-planar face means all the vertices of a face don't exist on the same plane. So we have 3 up here and then 1 down here. The problem with that is it's going back to Maya. Right now, the fact that I'm seeing this shaded, that's Maya being a bro. That's him helping it, him or her helping me out. So I can kind of see that surface. But right now, it doesn't know where to break that polygon. That whole idea of like me right here, looking and seeing the fact that it looks like it's breaking it that way, that is how it's breaking it at that point. Maya makes that decision per frame. So if I have like, 30 frames per second and like several seconds going by, it may change its mind repeatedly. All right, it may break it this way, or it may break it like, let me go right here. It may break it this way, or on another frame, it may break it this way. And it'll just make that choice depending on where the camera's at and what frame it is. And then we'll get this weird flickering look. How many people used to play PlayStation games back in the day? Anybody ever wonder that weird popping you would see on like some of the character models? That was it. Yeah, right there. Sometimes like a polygon would be bent in a certain way and wouldn't know which way to like pop in and out. That's one of the reasons. So now, why is that not an issue? Well, obviously, if it's that extreme, that needs to be fixed. All right, we can fix that by bringing that up and making sure that it is on the same playing field as that right there. So we can use snapping, get that all flat. But here's the thing. That right there, that is still considered a non-planar face. That little bit of degree of me pushing it down. And honestly, you're not going to be able to build your objects without some level of stretching of your polygons. So that's why I usually say, hey, if it is an issue with non-planar faces, trust me, from a distance, you will be able to see it. But that right there, I don't really worry about non-planar faces. Same way with the next one, which is concave faces, which is literally when we start like pushing this into itself. And we can already see when we go too extreme, whenever we see what looks like an edge, but there's no edge there, that is an issue with our object. Going back to our polygon face has a surface area. So think of it as like a handkerchief. If I pin down 3 points and I start taking the 4th point and start pushing that in, what happens? It starts bunching up in the middle. That surface area has to go somewhere. Same way with right there. It's overlapping onto itself. So that's where we start getting extreme. But some of our surfaces have some level where we have it like that, where we're approaching like, having a quad that looks like a triangle. That's just part of modeling, all right? We just need to go in there and just slightly adjust it and pull this back out just a little bit. So again, concave faces and non-planar faces, those are what those are. And they have very little wiggle room between what is considered a non-planar face or a concave face and what isn't. It literally comes down to a few degrees, all right? So I won't worry too much about them. The next two, you have to. They are tool breakers. They will mess everything up. First one is lambda faces. Lamina, which is, we go right here, grab all the faces, kind of extrude them in. And that's one way right there, which is pretty much faces that share all their edges with each other. Essentially means a face on top of a face. Like literally there's two faces that inhabit the same space and they're connected to each other. Think of it as like a weird like pizza pocket, all right? The thing is that can't exist. That happens most of the time because of that shift extrude. Sometimes when you go to extrude, you may accidentally click out the tool or extrude by accident. Well, the thing is, even though it's an accident, it still leaves that surface behind. So we have to go back and make sure that we clean that up. The quick way to do that is, one, if we accidentally do extrude, so let me go right here. So let's say I extrude this edge right here. Extrude, but then I accidentally click off. All right, as far as I'm concerned, well, I didn't extrude. So let me go ahead and grab that again. And this is the first thing that should be a sign that I did something wrong. I'm double clicking on this edge. What should be happening? It should be grabbing all of them. That's my first sign. Maya's not doing exactly what I want to, all right? So I ignore that. So I just go right here. I select all that and deselect this because I'm just like, oh, Maya's being dumb. And then I'll hit extrude again and pull that up. Well, the thing is that that surface is still there. If I pull that up right there, man, there's that surface that is still there. It has no surface area, but it still exists. That is lambda faces. That it's left behind. To fix that, the easiest way to get rid of like extrudes that are on top of each other, can anybody think of it? Merge. Pretty much the same logic with our mirror. The idea is if it's on top of itself, then that means the verts are on top of itself. So I can just grab all my verts right here, merge, and then just tell it to merge down to a very low number. And now I should not have that phantom area. Another thing is, and actually I'll probably save that for the next one. So, all right, so that's limited of faces. That usually happens most of the time when you accidentally extrude when you don't mean to. That's why extrude can be dangerous. It can kind of snowball. If you forget about extrude and you don't catch it in time, you're literally compounding that extrude each time you try to extrude over it. All right, so you want to always kind of go back and double check. And then the last one, which is literally the worst offender. So bad that there's actually 3 forms of it. And it's called non-manifold geometry. It's geometry that blah, blah, blah. Let me rephrase this. All right, so non-manifold geometry is literally geometry that can't physically exist. All right. What does that mean? Well, some of these are going to sound like riddles from the labyrinth. But the first one is non-manifold geometry 1, which is you cannot have an edge shared by more than 2 faces. What does that look like? Well, it looks exactly like what I just did, which was I grabbed an edge like so, and I extruded it out. Why cannot that not physically exist? Close. Think of this right here. So technically my plane is 3-dimensional, but now I'm pulling another edge out of it that has no dimension whatsoever. The best way I can describe it is if I walked over to Brian or you and I grabbed hold of one of your like atoms or cells and I pulled out another you, right? I cannot pull out a new surface out of something that already has depth. So essentially, this is an edge that is shared by more than 2 faces. So we have that third face. The good rule of thumb is, for the most part, do most of your extruding on faces. The only time I would really do extrude is if it's a border edge right here. And now the quick way to fix that, just get rid of that. Why is that important? Well, that form on manifold geometry happens if we forget to get rid of these surfaces on the inside. So that's why we had to get rid of that. All right. Now the next one right here. I'll try to get through the rest of these really quickly. So next one is this. Reverse right there. How many people have been seeing black faces on their geometry? All right. Has anybody thought about what that means? That's true. It's not supposed to be there. All right. So what does that black face mean? Well, it's inside out. That face is literally not getting light. That's all that means. Is because the fact is that really polygons only have one side. How many people have played a video game where they're like running around and they somehow get the camera inside the character's head and you see the eyeballs but you see like through the skull, that kind of thing. That's because polygons only show on one side. That has been like, a hardware and resource management and like saves us time. That's because polygons only have one side, which faces their normal. So think about the way that I'm facing. Think of me having an arrow sticking out of my chest. That is my normal. That is the face that that is the direction that I'm facing. And that's the side that is going to get light. If it is black like that, that means it's facing the opposite direction. To kind of give you an idea, I don't know if anybody's ever seen their model get green hairs. Has anybody seen that? All right, sometimes it can get to happen with like a hotkey, but I'll make it happen that right now. So if I go right here to face normals, now I get all these green hairs. Those are actually my normals. That's showing which direction my face is facing. And that brings us to non-manifold geometry 2, which is We can't have two faces share an edge but be facing opposite directions. All right. So the way that we can fix that is we find those faces, select them, and then go to Mesh Display, Reverse. And that's how we fix that. We just reverse or normals, tell them to face the other way. Any questions about that? All right, and then the last one. This is the most riddle one of all, which is we can't have two faces share vertexes but no edges. All right, they can't be connected by just a vertex. All right, that's like me and Brian being connected by a single hair. Doesn't happen. So we have to make sure that there is at least an edge connecting them. So what does that mean? We just probably need to either go back and fix that, or that way now we have edges connecting there. And as you can see, I just went back and quadded that up as well too. And now that's all corrected. So, how's everybody feeling with those concepts? Now, you're not going to know exactly how to fix these automatically. It takes years of practice to get used to it right here. But we will have several different chances to kind of go with that right there. Usually, going forward, each week, I try to make a point of, like, during lecture, I will handpick some of y'all's models. I'll get rid of the names, but we'll sit down and actually fix them as a group. All right, go through them all. How we do that is using, actually, first let me kind of jack some of this up so we can kind of do that. All right, that should be good. All right, so how many people can spot the issues? Huh? One? Anybody else? All right. Here's the thing. You don't have to do this all by your lonesome. We do have a tool that will find this stuff out for us. All right. It lives under Mesh and it's called Cleanup. Go right here, Mesh, Cleanup. And what we want to do is hit the option box. All right, with the option box right here, we have a couple options right here. So first, we have operation, which is we get two options. We get Maya can clean up for us, or we can have it just select it to show it to us. Which one should we do? Select and show us. Remember, Maya doesn't have a brain, doesn't have an artistic ability. It will just kind of correct it in a way that makes sense to Maya, which can jack up your stuff. So we hit selecting. Next, we have our scope. We have apply to all selected objects, or we have apply to all. This depends on what you want to do. If you want to see what's wrong with everything, we can have apply to all polygon objects. Or if we need to focus in, we can just do it on selected. Next is our criteria. All right, so everything I just showed you has a checkbox. We have faces with more than 4 sides. That's n-gods. We have concave faces. We have non-planar faces. We also have lambda faces. We have manifold geometry, things like that. So, and then also we have faces with holes. That's kind of hard to make on accident, so I don't really go over it. I let that be like, you know, a case-by-case basis. But usually what I have turned on is faces with more than 4 sides, faces with holes, lambda faces, and non-manifold geometry. And then I hit apply, and then it lights everything up. All right? So now we know what's wrong. So this is where people get exhausted. Not just, the fact that I've been lecturing for like 3 hours now, it feels like, but the fact is that like that gives you too much information. All right. And that's what happens from time to time, is that this is too much information taken at once. So you have to put on your blinders. You have to take it step by step, because each one of these has a different fix. All right. With InGuns, it's literally just taking your multi-cut tool and start cutting in up into quads. Faced with holes, same way. We bring out our multi-cut tool and connect that all up. So we need to start focusing one by one. Now that we have an idea, we turn everything off, and then we go bit by bit. So face more than 4 sides, hit apply. All right, selected those. Let's see what's going on. So one of the first things I'll do is I'll go to vertex mode and see if there's extra vertexes. There is. I can delete those, and now that should be fixed. I'll just select that, hit apply. If it deselects it, that means that we fixed all the InGuns. Next is faced with holes. I'll have that selected, hit apply. All right, they all disappear. Nothing's wrong with that. So we move on to the next one. Lambda faces, hit apply. Nothing popped up, so that looks good. And non-manifold geometry, apply, and it lights up like a Christmas tree. All right, from there, we have to decide what is wrong. So first, we will look for anything that is kind of like sticking out. So these right here, that's one form. So we get rid of those faces. And then we'll hit apply. And it's still highlighting these verts. So usually what I'll do is now go right here to vertexes, select them all, go to merge verts, and tell it to merge down to a very low number, 0.01. Hit apply again and see if that fixes it. And now everything's fixed. The key is to go bit by bit. This is honestly going to be a complex thing because everybody's been building so far. Now the hard part's going to be cleanup. It may seem like I'm skimming it over, mostly because I am. The fact is that we do have an amazing 3DF video that kind of goes through all the instances. And 2, guess what we're doing Monday? Oh, Wednesday is UVs. Monday is we're actually building from scratch something from level 1, which also means we're going to be fixing it as well too. And then also on Wednesday, if we get done with UVs in enough time, we will be taking some of your objects and also cleaning those up. Throughout the month, we will be going through and fixing as much geometry as much as possible, because I can go right here and screw up a plane as much as possible, but that's not going to really help you. The best way to show you is to take your own stuff and go through how to fix it, because those are real world cases. Real world cases for us to diagnose. Any questions? What's up? You do? I've been talking for too long. All right. So what do you think? Tuesday, Thursday, and Friday. Oh shit, I can't do it. All right. So with that said, how's everybody feeling about that so far? All right. So that is the lecture part of it. Now let's talk about your actual projects, what you're going to be turning in. So we run everything as if we are your clients, and we expect your stuff to be turned in professionally, which means you need to make sure that you are going through and doing all the clerical stuff. So I'm not going to go through it because we have some short videos that will take you step by step, which is 1, making sure that you do your professionalism. So that is the part where you go back and organize all your stuff. So going back to you built Optimus Prime. Well, obviously, hopefully you went back and actually named all the pieces, put them all in groups. So like, the head parts are not like mixed in with the leg parts and all that stuff right there. You don't want your like texture artist to have to do the hokey pokey to figure out what the hell you modeled. All right. Fact is, it's your job to make sure that your stuff is cleaned up and organized. This will take you through how to group stuff, name stuff, layer stuff, delete history, freeze transform, center pivot, and how to also set up the presentation, which is making sure that you go into the viewport, you make sure that everything is Res 1, which is select everything, hit Res 1, and then also that it's in wireframe, and then how to properly name it. Next is going over how to get your files ready. So what you want to do is, this will go through how to take your project folder, copy it, and then pasting a new copy to your desktop so you can modify it. You never want to modify any of your original stuff. But the idea is that we don't need every one of your prior saves. We don't need any of the other stuff that you may use to model, all right? We only need your final project, which is your final save for your coil. You're going to go through and clean out your folders and make sure that it matches up with this. This is your legend. It goes through every folder and what should be in there. So we have a lot of folders that have nothing. And then we have the scenes folder, which is going to be your main save, named that way. Same way with your source images. We only want your references. We don't want any like random, images that you found online that you thought was hilarious or cute or anything like that. We've gotten that before, all right? We don't need memes when we grade you. So we only want that right there, just mostly because there is a lot of you, and that can make for a very big download. Make sure that you go through all of those. Everybody understand that? All right, good, because we also treat that like as in the industry. If you mess up how you submit stuff, you can also mess up the pipeline, which is if you mess up turning this in and it's not turned in the way that we want it, it's automatically considered 1 day late and it's 10 points off. All right, this literally should only take about like 20 minutes to go through. Make sure that you set that time aside. But yes, if you do not do that properly, it's automatically 1 day late. Any questions about that? All right, next is everybody, I see most people have put up their FSO pictures and updated their FSO profiles. You still have time to get those extra 5 points if you want to. Just get that done by the end of Sunday. And then lastly, let's talk about our late policy, since I've already brought up like the late thing, which is 1, please don't be late. That's the main thing. Deadlines are more important. So if you feel like you're going to be late, sometimes it's better to just submit and then move on to the next week's stuff. All right. Now, with that said, we do know that stuff happens. So how it goes is, if you're going to be late and if you need that extension, make sure that you email either me or Brian, or if you're online, whoever runs your online section. If you're not sure who runs your online section, look at the picture. All right. But the fact is that you need to email that person and let them know that you're going to be late, because they actually have to give you an extension on the FSO page, or you will not be able to turn anything in. After that, once we get that email, it is 10 points off per day after the deadline, up until the end of the 3rd day, which after that, we don't even grade it. After that point, it's failing grade and it's already taken too much of your time. You need to move on to the next thing. If you're going to turn in late, make sure that it's worth it, because that is a hard amount of points to make past, all right? A lot of people say, hey, I'm gonna be 3 days late, but I'm gonna make 100 on my project. I'm gonna make a 70, it's gonna be good. But the thing is that most of the people that turn in on Wednesday, they end up with like a 10 or a 20, all right? Not in deductions, I mean a final grade for that project. All right, so make sure that it's worth it. You're turning in a complete project. And again, it's better to just turn in what you have on Sunday. Believe it or not, your professionalism that I just showed you, I think that's like 40% of your grade on the week 1. So even if you're not completely good about your model, if you get the professionalism done and get that turned in, you'll have like a decent grade for that, at least that first week. And you can always make up and try to get that coil done next week. All right. Any questions about that? All right, one last thing, and I'll shut up. Also, it is on you to figure out what you want to be graded. It is not our decision what's supposed to be graded. So make sure that you're clearly labeling your stuff. Do not turn in a bunch of scenes and make us decide which one we're supposed to grade. All right. Also, if we've already graded your stuff, you can't submit something in again. Once it's graded, it's graded. All right. So it's up to you to make that decision. So again, make sure that you are turning in exactly what you want to be graded. That way that there is no question about whether or not it needs to be graded. Outside of that, if you have any questions, let me know. Other than that, campus, go ahead, sign in, come back by 5:45 p.m. and definitely make sure that you use your lab time wisely. That's what like Sarah and Wade are here for. They're here to give you critiques, answer your questions, so on and so on. What's up?